Good morning or afternoon. This is Mr. Cohen coming to you from the Algebra 1 testing area. And we've got base area and lateral area for prisms. These are notes for 11.2. There should be hearing technology for those of you who do not have AirPods. Just ask the sub or whoever's filling in for me. Or if you're in the Commons, they're in my room in a bucket. So we're going to go over the base area and lateral area. We're going to start with the base area formula. That is going to be B times H for quadrilaterals. And that can be defined as B times H all over 2, and that's how you'll type it in your calculator for triangles. And then for polygons, apothem times perimeter, which is just the number of sides, times the side length, again divided by 2, which is how you put it into your calculator. Calculators are in the back bookshelf as you walk in my door. Polygons. So find the base area of the following prisms. Notice we've got a base length of 8. We have a base width of 4. We have a height in general, we can get to that later, of 5 meters. And we're looking to find just the base. So that base, and there's 2 of them, is base equals, might be faster for me to just type this. Let's see, get rid of the drawing. And click that off. And we'll go with it. So our length is 8. Our width is 4. Why do I say there's 2 of them? Well, there's another base up top, and that's also 8 by 4. So I'll use times 2. And let's go home. Let's see if I can just start typing. So we'll go with 8 times, 8. That is tiny. 8 times 4 times 2 equals 64. Don't forget your units. That's meters squared. For a regular triangular prism, we have a base here, length of 10, and this is a regular, meaning all sides are equal. So let's go back into draw and take a look at that. We have 10 and 10 and 10. So we're trying to figure out our height. Without going too much into special right triangles, recall that, let's go home again, recall that we have 10 times square root of 3, and that's because of the base being split in half, 5, and that's square root, SQRT, 3, and that, all of that needs to be multiplied by the length of the base, so that full base actually is 10, so times 10. Height again, or median, is 5 squared to 3, and all of that's going to be divided by 2. And finally, we've got a regular hexagonal prism. Finally, we're getting into some polygons. So if we take a look at polygons here, I've got 6. This is hexagonal. So a hex, and it's creating smaller triangles that are also 1 square root of 3, 2. In this case, it's 3 square root of 3 because of the sides all being 4 foot. Half of 4 foot is 2. And let's see, we've got 4 squared. And we're using the half. So let's go with 2. So we can get back into this. 2 square root of 3. Each side is 4. So we'll multiply that by 4. And there are how many sides in the hex? 6. And then finally you've got 2. You have a base on the bottom and a base on the top, which looks like this base and this base on the bottom. So don't worry too much about the final answer as much as how do I set it up, what do I use, and those base area formulas are on your laminated sheet, again in the back of the room. Lateral faces are something different than the bases. There's bases, but there's also faces. So when you're figuring out your faces, you want to use on the side instead of top or bottom. And when you have the lateral area, you're not including the bases. So this is non-base faces area only. To find those lateral areas, we're looking at 2 times 8 times 5 for the first one. And so we have above here, we have an 8, we have a 2. They kind of disappeared, but 8, 5, and 4 should be on your paper. So 8, 5, and 4. So we're taking the 8 times 5. We're doing the 2 sides plus and 2 of them. Now we're going to add the smaller sides to the left, to the right. We've done front, we've done back. We'll do 2 times 4 times 5. And now let's take a look at our regular triangular prism. We know that there are 3 sides. There's a left, a right, and a back. Those are faces, not bases. So 3 of them. We know that their width is 10 because the regular triangle is 10 by 10 by 10. And we know that the height is 50. So we'll multiply times 50. I think I can do this fast enough. So that's going to be 3 times 10, 30 times 50 equals 1500. And that will be meters squared. the total here, if we go back a little bit, is equal to 120 meters squared. And then finally, for our regular hexagonal prism, we're going to take only the faces. There's 6 of them. It's, let's say, left front, left back, center front, center back, right front, right back, 6 for total, times 4, which is the width, times 12, and that gives us 288 feet squared. Probably the easiest thing we can do is finding the total areas now. And that's just a matter of adding what we already came up with for our totals. So I get back here. Guess not. Gives us a little bit more space. So we've got our 120 plus our 64. So our original was 64 meters squared plus 120, whoops, plus 100, and just decided to eat it, didn't it? (120 meters squared), and that equals 184 meters squared. For our regular triangular prism, we're adding the original 10 times 10 over 2, which was, 2 times 10 times 10 over 2. If I shoot up here, it might still show up. Hello. 2 times 10 times 10. So this one was 2 times 10 times 10 all over 2. That's going to be 100. And then it was 100 meters squared plus 1,500 meters squared equals 1,600 meters squared. And for the final one, we're going to add the 42 feet squared, 42 feet squared plus the 288 feet squared, and that equals 330 feet squared. Next up is going to be volume. Stay tuned.